All right, today we're going to go ahead and discuss converting binary numbers to decimal numbers. And first thing we would want to do is review what a binary number is. A binary number would be a number that is expressed in zeros and ones. Zeros and ones. And so numbers that are expressed that way we can actually convert to decimal type numbers, and a decimal type number would be a number such as the example here, 192. Which is just a whole number. And so how do we do that? Well, there's an actual process to go ahead and do this. So I'm going to go ahead and select my number 0, 1, 0, 1, 0, 0, 1, 0 again. And this has 8 different numbers, 1, 2, 3, 4, 5, 6, 7, 8 positions. Well, the way this would work is that each value would represent a number of bits that would double as we move this way. So 1, 2, 4, 8, 16, 32, 64, and 128 would be the way that that would work. So I'm going to just go ahead and draw a little box around these so that we can actually see how that would work. Okay, and so each of those numbers, let me bring this up here. This would actually be better if I rewrote it. I'm going to go ahead and do so now so it works a little bit better. Here we go. It's going to be a 0, 1, 0, 1, 0, 0, 1, and 0. There we go. So we'll do it just like that. Okay? So again, this binary number here is expressed in bits. So this would be the first. We double it 2, 4, 8, 16, 32, 64, and 128 bit. And the way that is represented is this would be a value of 2 to the 0 power, which is equal to 1. And this would be 2 to the first power, which 2 times 1 is 2. 2 to the second power would be 2 times 2 is 4. 2 to the third power is 2 times 2 times 2, which is 8. 2 to the fourth power, which is 2 times 2 times 2 times 2, which is 16. 2 to the fifth, 2 to the sixth, and 2 to the seventh. Okay? And so that would be the way that this system would actually work. So in order to determine what the value of a particular number is, we've got to go ahead and see where it's represented. So like for this one right here, it's an off position or a 0, so there would not be a 128, so it's going to be a 0 plus. This one right here is represented with an on position or a 1, so that would be a 64. This one right here is a 0, so we're at a 0. This would be an on position, which is a 16, so it would be a plus 16. This would be an off position, which is a 0. This would be an off position, which is a 0. This would be an on position, which is a 2. And this would be an off position. So if we want to see what the decimal value of this particular number is, all we'd have to do is add these up. And all I did was take the on positions, and those values get added together. So 64, 16, and 2 get added together. So if I add 64 and 18, that's 2, carry the 1, it's going to be an 82. 82. And so if I want to go ahead and check and see if that is an actual value for that, what I can do is I can do it one of two ways. I'm going to clear this one out, and I'm going to put my binary number, let me get the calculator out of the way, my binary number here into my calculator. So that's 0, 1, 0, 1. Oops, let me clear that. 0, 1, 0, 1, 0, 0, 1, 0. And I'm going to go ahead and convert that to decimal, and it comes out to 82, which is the answer that I have right here. And so that would be how we would convert a binary number to a decimal number.